I've finished turning a bowl. I got the inside turned and the outside turned pretty much done. I am in need now to finish off this bottom. The pride of a wood turner is to make sure that a client looking at the bottom of the bowl won't see where it was being held. So a turner wants to get in here at this point and finish off the bottom. The industry for many years has given us the alternative of using what they call a coal chuck. And basically this chuck can be adjusted to some extent by just like a skull chuck. I can tighten it up somewhat, or I can loosen it somewhat. I've got an inch or so of play there. If that won't grip the bowl either inside or out, however I want to do it, then my alternative then is to get out an Allen wrench and move these 8 grippers. I can, if it's not large enough, I can move it out. If it's too large, I can move it in. I have to unscrew and rescrew those 8 grippers. To do that, it's not a trivial thing, and it's very frustrating. A lot of turners go to an alternative of just using a flat plate and pressing it in and trying to turn the bottom off then, and you have to then carve off a little nub that you leave to hold it. So what we're going to show you with this video is an alternative to that, called a Longworth chuck. The Longworth chuck, and this is an example of one that's very large, it's 20 inches, is self-adjusting. You don't have to unscrew anything. You just go to a small bowl or all the way out to a large bowl, and then just tighten it back up on the bowl in order to grip this and turn it around. Roughly center it. There's little holes in here to grip. Make sure it's up against that. And then you come around on the back of this thing and tighten up wing nuts. Alright, let's see what one of these chucks looks like when you disassemble it. On the back you have what we call the spindle adapter. This piece of walnut is threaded with 1 1/4" 8 thread to go on my 3520 lathe. It's threaded right into that wooden block. And while we're on the back here, let's remove these grippers. And we'll turn it around. There's one screw that goes through the middle, and into and almost through that spindle adapter that you saw back there. So it's a very strong connection. That base disc has spiral arcs that go out and to the left, and that disc is attached with 4 screws into this block of walnut. So when I put the face disc on here, you'll note that instead, since these arcs are out to the right and the arcs on the base disc are out and to the left, what we see is just a hole through here. That's the hole that we put our grippers through. whole scheme of this is to get a point directly in the center from which everything is going to be referenced. And when we get a point in the center, we'll drill a vertical hole down through both discs, and that will be the reference for both of them. So the first step is to draw a diagonal corner on all four corners. Now that diagonal there, that point right there is the center of everything that we're going to do. So the next step we're going to make is we're going to drill a hole through that center. In order to make sure that I'm getting right where I want to get, I'll take a center punch and make a dimple there that I can put my bit into. I have a gauge here that I made that has the proper size hole in it, so I know I'm holding the drill straight vertically. Now I know that hole is going to be vertical. But I want both of these, the front disc, which is 1/4 inch, and the back disc, which is in this case 3/4 inch. I want to have them both have that same hole right directly in their center. So I go through the first hole that I did, through my gauge, and through the second. So there's a hole here in the middle of that. Now I'm going to move this out of my way and go back just to marking this. So I'm going to use a compass to draw my first circle relative to this center hole that is going to be a 1/2 inch wider than what my ultimate spindle adapter is going to be. So the spindle adapter is going to be 3 inches, so I'll make this 1.5 inches, and then come out to about 2 inches. This doesn't have to be precise, and this is going to be circle number 1. And we'll explain what these are all about as we go along. Now the next circle that we're going to draw is going to be the actual outside edge of our disc, which is going to be about an 8-inch radius, and we're going to make that very dark. That's the outside of our ultimate disc. We're going to take this to the bandsaw later and cut out that circle. Now we're going to come back in a little over a 1/2 inch, and this doesn't have to be really precise. And we're going to draw our second circle. Measuring the distance between the first circle and the second circle. Remember, this is number 1. This is number 2. We're going to make another circle. Now this is 5 1/4 inches, so we're going to go to 2 5/8. That's halfway between circle number 1 and circle number 2. Set our Dremel up. Again, this does not have to be really precise, just close. And we'll put in circle number 3. Then again, we'll measure between circle number 1 and circle number 3, and we'll make another circle. We're about 2 5/8. A 1 5/16 would be about the middle of that. And we make circle number 4. Now, using a 45-degree triangle, we're going to make another radial off of those cross radials at 45 degrees to the cross radial, and then extend that up the other way, going through that center hole. Now coming off 90 degrees to that, and extending that over. Now we're going to strike an arc, and we're going to do it from circle number 3 back to circle number 1. And set our point into circle number 3 where it crosses a radial, and we're going to strike an arc out from circle number 1 to circle number 2. Then we're going to look carefully at that to make sure that it doesn't interfere with our process as we go along. There's going to be a hole where each one of these radials cross circle number 3. And if that arc gets too close to any one of those, it will get close to all of them, so we have to move it. And in this case, the arc is within about 1/8 of an inch of where I want to drill a hole, and I feel that that's too close. The only remedy I have to that is to increase or decrease the radius of my arc, and I'm going to choose to increase it about another 1/4 of an inch, let's say. And I'm going to draw another arc again from that hole, and I'm going to look at how close that comes. In this case, that is about 3/8 of an inch away, which I feel is adequate. So I'm going to mark all of these intersections. Again, it's number 3 circle, and each one of the radials. And now I'm going to drill a hole through those intersections, through this piece and through the next piece. But before I do that, I need to make sure that these things are fastened together and aligned. I have both the piece that is going to end up being the front piece of my chuck, which we call the face disc, and we have the back piece, which we call the base disc, and they have to be collinear. So I'm going to use the nail through that hole that I drilled earlier and into. So now I'm going to drill a hole and countersink 4 small screws drill a hole through here as far as I can get out on the edge to stay out of the way of the trammel as I go along with the router. Now, of course, countersink just so these little screws, which incidentally are just number 4 by about 3/8 of an inch, just enough to hold that. They're flathead screws. So once I get them screwed in there, they'll be below the surface. I had this nail through the center holding these coaxially while I put these 4 screws in the outside to hold them together, and now they are basically one piece. So when I route my arcs, they will be at the same place through the 2 pieces, and everything will be aligned. Okay, now all I have to do is to get rid of these extra marks that I have out here, and now I'm going to drill holes in each one of these junctions that again are going to be vertical. And the way I'm going to do it in this case is I'm going to take this to the drill press. Okay, now we're going to put a dimple at each one of the intersections of the radials and the circle number 3. I'm going to be very careful in doing that so that they all are coaxial. Putting that dimple there helps me when I get to the drill press to draw a nice vertical hole in just the right place at that intersection. I got off on that. Okay. Now that we have all of those holes drilled through the faceplate and the base plate, we can put our trammel point into the holes we just drilled on the drill press, and we can strike an arc that will not interfere with the holes. And then we move to the next radial and we repeat the process. By doing this, we notice that the arc, the second arc, terminates very close to where the first arc went, and that will weaken our disc. Now, given the purpose of these Longworth chucks, we realize that we don't really need to have anything that close, that small. We can hold them in other ways. So we can terminate our arcs almost any place we want to, but we don't have to go that close. Now, traditionally these arcs have been terminated at circle number 4, where you take one arc that goes all the way to circle number 1, and then you stop subsequent arcs at circle number 4. But we don't have to do that. And given the fact that these are going to be very small bowls indeed, if we did that, we can change our strategy somewhat so that we can still hold a pretty small bowl but have all of the arcs go to the same place. And that's what we're going to do in this particular case. So I'm going to stop drawing my arcs and reestablish where I want them to stop. In this case, I'm going to use my radials as the stopping point, and I'm going to come here and start drawing this arc from the radial, the 90-degree radial here, out to the number 2 circle. And I'm going to go back and I'm going to end my first arc at the 45-degree radial, and I'm going to erase this here so it doesn't confuse me, and I'll clean this up later before I start routing. Now I'm going to continue making my arcs, stopping at the radials each 45 degrees away from the last one, and my arcs are going to come in just to that radial. I'll move off another 45 degrees, draw another arc between circle number 2 and the radial, the next radial. I have 1, 2, 3, 4, 5, 6, 7, 8 arcs that go between the radials that are 45 degrees separated from each other out to circle number 2, and none of them come close enough to be a problem for any of the others. Now that we have our 8 arcs out here, that's where we're going to route our slots. And we'll do that in a minute, but we made a compromise a few minutes ago and said we were only going to go to the radials instead of going back with some and stopping at our circle number 1 and stopping at the alternates at circle number 4. We decided we'd stop at the radials just as a reference point. Now that means that this is our new circle in here, and I'm going to put it in here, and that's as far as our grippers are going to be able to move, plus the radius of the gripper. So how small a bowl can we expect to be able to hold with this? Well, looking at the radius, and let's go from 10 there, that's 2 3/4 of an inch. So what's that? About 5.5 inch bowl would be as small a bowl as we'll be able to hold on that thing, and I think that that's perfectly adequate for this kind of a do now is cut this thing on the outside perimeter line that we drew in heavy before. What I've got is a line on this sacrificial tabletop. I have a line that goes out 90 degrees to the blade, and I've gone underneath here and aligned this radial with that. So this nail will go into my sacrificial table. I'll drill a hole down through there, just to set it in, give it a tap, and that will center my piece on the tabletop. And we'll start it. Perfectly round set of discs. The front disc, the face disc, it's got all the marks on it, and the lines, the arcs go out to the right. And I pull off the bottom. It has the same arcs, but when I turn it around, those arcs go out to the left. When I put them together, there's only a hole where those two arcs cross, and that's where I'm going to put my grippers later on. So, drilling finger holes so that we can move each one of these discs relative to the other as we need to. I use a nail set to make a good dimple where my mark is, so that the center of the Forstner bit will find that dimple and align where I need to be aligned. We've decided to make our Longworth chuck to be so that we can grasp the spindle adapter of this thing with a scroll chuck. To do that, we need to make sure that when this disc gets into the scroll chuck, the scroll chuck bottoms out on the bottom side of the base disc. That's the reference for everything, and that'll keep the run out as close to zero as it's going to get. So what we're going to do here now is true this up. I've screwed a piece of 1/2 inch plywood, which is just a little bit less than 1/2 inch. I've screwed that onto this faceplate, and I'm going to true it up. Out this drill bit into a Jacob's chuck. By using this 1/16 inch drill bit in the Jacob's chuck and drilling this hole right here in the center, we know that that hole is now centered with the lathe, and we'll use that for our reference point from now on. so now that's dead flat and centered with the lathe. Now the next step is to get it centered with the base disc, and we're going to do that with a nail. This face of the face disc is going to curve out and to the right, looking at it from the tailstock. When I take that off, I'm looking at the face side of the base disc, and that is obviously going to swerve out to the left. I'm going to put my nail in there and put it into the hole that I created in the spindle adapter, and that will be the base disc. By putting the nail in here, that makes sure that the base disc is centered with the lathe, as is the spindle adapter on the back. So now the idea is that we're going to have to attach this to that spindle adapter. But what we're going to do is we're going to drill 4 holes in here and countersink them and put 4 screws in. Alright, now we're going to make sure that we mark this base disc and the small disc that we call the spindle adapter, and we're going to do that by putting a mark on the spindle adapter and on the base disc. Now it has 4 screws through it, and it's glued and screwed, and the lathe tailstock is holding that in long enough for us to get the screws in there and to get it aligned. Now, in order to make sure that the screws went in there right, we measured the shaft of the screw. It's a little over 1 1/8 inches, and then we made a clearance hole in so that the screw went through the base disc and into the little disc there that we're using for our spindle adapter, and got a good bite on that. So now the spindle adapter and the base disc become one piece. It's glued and screwed together, and we don't have to worry about it coming apart. Put the scroll chuck back on. This little disc does not bottom off in the scroll chuck. The back of the base disc here is the face of these jaws, because we have sharp edges on here, and if you leave sharp edges on MDF, they'll break away on you. The first thing we're going to do is come in here and round these edges off. Put a little radius on the edge and make sure that any run out is removed. We're going to use this 1/4 inch by 1 1/4 inch screw, machine screw, to hold the face plate onto this base plate and spindle adapter. And to make that happen, we're going to tap screws, machine screws, into threads into the base plate and the spindle adapter. So the drill bit I have in there is the tap drill bit for a 1/4 20 tap. So we'll drill that hole now, and that will go right dead into the center. And put the tap in. on center. And without fastening anything down here, everything is loose. I'll start turning that to start that thread. Then loosen it up. Put the tap wrench on. Take that little pucker off there. Okay, I'm going to drill a clearance hole for the bolt that's going to screw into these threads to go through here but not bind on it. So I'm going to put, I've got a 1/4 inch drill, and I'll drill right straight through that hole. 1/4 inch bolt with a fender washer on that. And we just thread it into this. Our stoppers, which are our grippers, and put them through here. There's a washer on both ends of this stopper here, and put a fender washer on the back. Probably the most common way would be to put a live center in here and go into the very center in the bottom. Most turners will leave a little nub that they can get back to the center. Then I'd pull that up into that, and I might finish tightening this if it needed it. Then I'll go back here and tighten my wing nuts. Now, while you're turning, you're going to have high speeds out here on the peripheral of your chuck. It's always best to keep your tailstock pulled up, pressing that in until the very last minute. So while you're cutting the bottom of this thing and trimming it off and taking off this nub here, you keep this up until the very last minute, and then pull it back, make sure everything's tight, and then take off that last little nub. And at that point, the bottom's clear.